Good morning, everyone. I'm Brock. So today let's keep writing a lead code quiz. And we choose the topic algorithm. So let's get a random question. This one is medium level difficulty. So let's work on this one. So let's look at the question first. So the question is make axiographically smallest array by swapping elements. Well, I guess I don't know the English meaning for lexicographically. Let's look at the definition. So we are given a zero index array of positive integers and a positive integer. In one operation, you can choose any two indices I and j and swap numbers I and the numbers j. If numbers I minus numbers j smaller or equal to limit, return the lexicographically array. That can be obtained by performing the operation any numbers of time. An array is lexicographically smaller than an array B if the first position, well, A and B differ. Array A has an element that is less than the corresponding element in B. For example, the array 2, 10, 3 is lexicographically smaller than the array 10 to 3 because they differ at index 0 and 2 smaller than 10. Let's see one example. So here we have a integer list 15395. The limit is 2. And so firstly, we need to swap numbers 1 with numbers 2, which is change the position 5 and 3. Because they are the first, because they are the first number and the second number, right? And always remember that the first the zeroth number is a beginning of a list. So after the swapping, the array become 1, 3, 5, 9, 8. And then we swap number 3 and number 4. The array becomes 1, 3, 5, 8, 9. We cannot obtain lexicon smaller by applying any more operation. Note, it may be possible to get the same result by doing different operations. Okay. So it kind of like it's okay. So it's kind of like we want to get the list in a ascending sequence, but we cannot swap as much as we want, because here we have a limit, right? The two elements we're swapping must, the gap must be smaller than 2. Okay, so I guess I have some sense about what we need to do here. Let's think about how to work on this issue. So firstly, again, I think that we can use some test cases to figure out the basic, logic, how we execute this task. So let's get a test case first. Just let's use its example to see how the algorithm should go, right? 1, 5, 3, 9, 8, right? And the numbers list, and our list is 2. So what we need to do here is, as a first step, the first step is that we can sort, right? We can sort the sort by values, right? So what we get should be 1, 2, 3, 5, 8, 9. Right? So if we don't have any limit, this is a sequence we want to have. And also let's figure out the index of each value. So there's no 2 here. So 0 is in the value 1 is in the 0's position, so the index. And the 3 is 2, and the 5 has indexed 1. And the 8 has indexed 4. And the 9 has indexed 3. So we get pals, right? And the pals is a value and the position, or maybe index. So the first step, we want to, to rank the numbers, because if the limit, let's imagine if limit is infinite, then that will be the sequence we will export, right? But because of the limit, we cannot do that. So what do we need to do here? I guess that what the second thing we need to figure out, okay, what's the limit between each of those, slices, right? So I guess that we need to figure out components where their difference smaller than limit, right? That's something we need to do. And if that is the situation, So in our situation, limit is equal to 2. So the 5 tiles are divided into 2 parts. The first part is 1, 0. The basically, it's for the first part, we have 3 values, right? 1, 3, 5. And for the second part, we have 2 values, 8 and 9. Yeah. Okay, so then what we need to do is, what need to do now? Let me think. So for first component, the first component, we have the index is 0 to 1, right? Because we need to swap the value. And this comes from 0, 1, 2, right? Which means that the position need swamp. The position swamp will be So previous to 0 need to change to 1, and previous to right, the 0 is the index, and it's still the same. So and 0 is mapping to 1. And for the position, the index 1, it need to change to 2, and 2 maps to 3, right? And for index 2, it need to change to index 1, which maps to 5. Then similar strategy for the second component, right? The second component, the original dictionary is the original dictionary is is 3, 4, right? It need to change to 4, 3. And then position swap. The position swap is previous 3 need to change to change to 4, right? And 4 map to the data 8, and 4 need to change to 3, and 3 maps to the data 8. Right? After we make the two components swapping, then the output should be one, 3, 5, 8, 9. So let's summarize what we want to do here. So we sort the values first. Then we divide the component. Because limit exists here, so there's no guarantee we can always get the sequence in the ascending rank, right? And after that, we actually just sort each component separately. Okay, so based on this strategy, what we can do here is so let's get the lexicographically smallest array if the list is empty, then we just return it, right? And then let's get the how many elements. And also let's build a dictionary. Let's build an empty list to store the tuples. And then we need iterate over indices and values use enumerate, right? Iterate over indices and values. So for index value in enumerate numbers, what we need to do? We need to store the original index with its values, right? So we need to else value index, right? So in this way, we store the pals into the list. And then what we need to do? We need to sort the pals, right? To sort the pals, we can use the built-in function sorted. And so pals is what we want to sort. And the key is lambda. So so lambda x0 means we want to sort based on the first element, which is a value. And then we need to prepare the result, right? And let's put a 0 in the result first. And also we need to have compile values. So also let's use empty list. And we also need to compile indices. And let's get the value in front of it. So start from the first value. and put the first value into the compile. And append the first original index to compare indexes. Then we need to iterate through the remaining pairs by slicing pairs, right? And the pairs 1, comma basically means that yes, all pairs except the first element. And then we need to check the difference is inside the let's confirm what we want to do here. We want to iterate through the remaining pairs, right? From index 1 to the end. And then we need to check the difference between current value and the previous value is within our limit. So if value minus previous value is smaller than limit, right? Then what we need to do here? It's good, right? So we just put the value into the value list. And similarly, we put the index into it as well. And we move the pointer, right? Previous else is pointer. Okay. Else, if it's outside of the limit, then what does it mean? It means then we are done for this part, right? Because it cannot change. So we want to sort indices and values. Right? And then what we need to do? We need to assign the sorted values to sorted indices pairwise to get the lexicographic smallest placement, right? So which means we need to assign sorted values to sorted indices pairwise. Enumerate the indices. And the result and put the values into the results. Right, we need to put the corresponding value in the target index in results. Then we need to reset component list to start new component with current pairs. Right? Initialize compare values with the current value. Initialize compare indices with the current index. And also move the pointer, right? So after the loop ends, what we need to do? We need to process the final component, right? Remaining in process the final component remaining in component values and component indexes, where we can directly use sorts. And then let's assign each sorted value to each sorted index. Right? Position, enumerate. Right? And then let's return the result because we already put every component in the result. Let's try to review what we have done here. So firstly, we we rank, right? We rank the components, and then we try to see whether the difference between current value and the previous value is inside the limit. Then we began to sort each component, right? Okay. Outset of the function 971. Okay. Try it again. Least index out of range 955. So the least index is out of range. What sort of range? Maybe let's check from start. So if this is a real interview, right, and we are stuck here, well, I think that no need to feel panic. We can ask her, maybe the interview and get some feedback. And here, what I'm trying to do is, let's ask ChatGPT, right? So, debug. Error. So let's see whether ChatGPT has some insights about such a situation. Yeah, so if this is a real, conversation, just say, well, so first thing I noticed that most interviews coding interviews, actually the interviewer won't require the program to successfully run, right? But even if we don't get any, such errors like this, and we are stuck in some, algorithm strategies, we still can have a conversation with the interviewer, right? To say, hey, do you have some thoughts, right? So, okay, indentation. Okay. Okay, this loop to the outside, right? Okay. Okay. I guess that because, in the editor, the space is pretty small, and especially like a Python, right? It doesn't have the it doesn't have the brackets to distinguish different functions. I think it's pretty easy to, to have the wrong indentation. So I guess that for this function, no, yeah, let's try it again. This line still out of the. Oh, yeah, I should only, indentation line 56 rather than, the following three lines. So, okay, cool. It looks like the test case is passed. Okay, let's submit it. Okay, accepted. And yeah, so can you add few more test cases in comments to illustrate the algorithm strategy. I guess that before we write the code, think about a test case to clear our mind. And again, after we successfully run the whole code successfully and recamp our whole algorithm strategy, our whole workflow by some test cases are pretty helpful. Yeah, so it give a test case here, right? So this is the input, right? And the step 1, we need to sort the value and index. So 1, 3, 5, 8, 9, okay? Then we need to group where the difference happen. So then we group into 1, 3, 5 and 8, 9. And then we need to assign each group's sort value to sorted indices. So basically we need to map. I think this is not a good example because this is not a good test cases because itself is already, in the right sequence, right? This one also not a good one. 4, 5, 6, 7. So I should say are not good cases because limit actually don't make any difference here. Give some, edge cases. I think that, when we think about test cases, some edge cases is very helpful for us to, to understand the core idea of an algorithm. Okay. So now in the new test case, the numbers list is 10, 1, 12, 8, 5, and the limit is 3. So the first step is sorted pairs, right? 1, 1, 5, 4. 8, 3. Yeah, basically 1, 5, 8, 10, 12. This is the sorted pairs. Then we need to group them by value differences is equal to 3. So the first group is just 1, right? And the second group is 5, 8. The third one is 10, 12. And then we need to assign sorted value to sorted indices within each group. So index 1, I think for this part, assign sorted value to sorted indices within each group is still too high level, right? Please demonstrate in a fine grained. Yeah, and I think that when we think about the test cases, the deeper fine-grained we think about, it's easier for us to to clear our mind, right? If we just to write it too high level, when we write the code, it's very easy to miss in the details. Okay, so the first test cases it give here is, again, 10, 1, 12, 8, 5 limit, right? The first one, sort by value. Make sense? The second one is to form components by consecutive values. It also makes sense. So it's basically divided into two groups or two components, makes sense. And the third step is assign within each component, right? So for group one, we sort the indices, we sort the values, then we map them. And for group two, we sort the indexes, the indices, we sort the values, then we map them. And then we put these two components together, right? So index 0 maps 5, index 1 maps 1, index 2 map 8, index 3 maps 10, index 4 maps 12. So you see here, previous test cases, ChatGPT made a mistake here, right? If we just, take it as granted, then we will be fooled by AI. But when we ask for fine-grained details, actually it will help ChatGPT find its own error, right? So as you can see here, ChatGPT make a note. Earlier, I split this into 5, 8 and 10, 12. That was incorrect because the differences chain 5, 8, 10, 12 are all smaller than 3 consecutively. They form one component. That's also how we did with humans, right? Here's the store schedules. Socrates. Socrates, right? So you know Socrates. So you know Socrates. One of the most famous teaching style for Socrates is to ask follow-up questions, right? So when we ask fine-grained follow-up questions for AI, it's also a way to help AI find its own mistakes, just like you know humans find our own mistakes, right? Well, I think that's pretty much for today's quiz. Thank you, everyone. It's pretty a long video. Well, anyway, it's a practice, so I don't assume that people will saw it, so that's fine. It's more like the motivation for me to make this video. It's more like to force myself to practice at least one LeetCode quiz every day. I think that back in college, I would make a plan for myself, especially before try to find a job before interview. I will say, okay, I need to do a 3, 6, 9, whatever LeetCode quiz every day. But two situations happened. The first one is that I felt boring, and actually I didn't insist on my plan. And the second situation is I did that, but when during an interview, I don't know how to communicate with the interviewers, right? Especially if you have an English interview, something you even don't know how to pronounce. Then it can also make you feel more nervous and hard to think clearly in mind. So I think that's the biggest motivation for me to try to make a recording and publish it when I do this LeetCode quiz. Because if I can feel very comfortable to communicate my thoughts, then why interview with a interviewer, I will also feel comfortable to communicate with during the whole process, rather than just be silent, work on myself, and when I get stuck, I just get stuck. No, it should be like this. Interviews should always be a conversation. And if even from the long run, right? Even in the future, I don't need any interviews which I need to code for someone. I think at practice, a LeetCode quiz can also be a good practice to train our logical thinking. Because writing code doesn't like writing an article, an essay, right? Code needs to be very logical to be able to run. Well, thank you. Bye.